Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, IIT-Jam, Jest and other exams related to physical science. Okay. So this is the lecture number 2 of electronics, okay, in which we are going to study Kirchhoff's law and nodal analysis, okay. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science, okay. Okay, let's get started guys. This is Kirchhoff's law, okay. Kirchhoff's current Kirchhoff's current law. Okay, this is a German scientist, guys. Okay, and its pronunciation is Kirchhoff's current law. Okay, and in English we say Kirchhoff current law. So we can say Kirchhoff's current law, or in English it's Kirchhoff's current law. Okay, okay. So Kirchhoff's current law that we know, right, guys? We have studied in class 11, 12th. So very simple, right? So suppose this is the I1, this is I2, this is I3, and this is I4. These are the current, okay? So what Kirchhoff's law say? Incoming current equal to outgoing current, right? So Kirchhoff's law say incoming current, incoming, incoming current, incoming current equal to outgoing current. Okay, incoming current equal to outgoing current, right? So, so from Kirchhoff's law, that is I1 equal to I2 plus I3 plus I4. So this is the Kirchhoff's law or Kirchhoff's law. Okay, I1 equal to I2 plus I3 plus I4. Okay. Next guys, so I'll explain it by example. Okay, so for example, right, we have a circuit. Okay. Okay, this is R1, this is R2, and this is R3, and this is R4. Okay, so this is voltage E. Okay, so we'll solve it. Okay, we need to find the current in this circuit. Okay, so first you can see this R1. We can see R1, R2 and R4 are in series, right? So we can write since R2 is in series with R4, right? So then equivalent circuit is going to be like this. Okay, this is E, this is R1, and this is R3. Okay, and this is going to be like this, R1, right? and this is because they are in series, so this is going to be R1 plus R2, right? R1 plus my apologies, R2 plus R4, right? Because they are in series. We'll add if they are in series. So we I have already explained, right? Uh, if resistances are in series, then what is the total resistance, and if resistances are in parallel, and what is the R equivalent, right? So this is R1 plus R2. Now you can see R1 plus R2, this one that we can say, let's say it's R dash, okay? R1 plus R2 and R3 are parallel, okay, to each other, right? So R2 plus R4 is parallel, is parallel. Series I'm denoting like S, on parallel like P, okay? R2 and R4 are parallel to uh, R2 plus, yeah, parallel to R3, okay? R3. So R equivalent will find, R equivalent is going to be this, we know, right? So this is very simple, that is R3 into R2 plus R4 upon R1 plus R2 plus R3, right? So let's say this value is R dash, okay? Now again we'll make an equivalent circuit. So this is going to be like this, and this is R dash, and this is R1, and this is a very simple procedure, guys, this one, right? Now you can see R1 and R dash are in series, right? So equivalent circuit is going to be now like this. We have to find current in the circuit, okay? So this is, they are in series, so we can write like this. This is E, and this is R1 plus R dash. R dash is this value, okay? Let's see. Okay, R1 plus R dash. So now we can find easily current. Current I is going to be V upon R, right? So that is E upon R plus R dash. Okay, so this is the current, guys. This is how we find the current in this circuit. Okay, in this circuit, if we have such circuit. Okay, so this is the Kirchhoff's law, and this is the that this is the question, right? How we can find the current in the circuit. Okay, so the current in the circuit is I equal to E upon R. This is R1 plus R dash. Okay, R1 plus R dash. Well, next is we'll do nodal analysis. Okay, nodal analysis, very important, guys. And because by nodal analysis you can easily solve very complicated questions. Okay, so nodal analysis, nodal analysis we'll use KCL here. Okay, this Kirchhoff's law or Kirchhoff's law is called KCL in short. Okay, KCL, Kirchhoff's current law, KCL. Okay, so nodal analysis, nodal analysis, nodal analysis. Okay, I'll explain how we are going to find use nodal analysis and solve questions. Okay, so I'm going to make a figure first. This one, okay, and this is this one. Okay, so we have been given this circuit, guys. Okay, this circuit. This is R2, this is R1, this is R3, and this is R4. Okay, so we have to find current. Okay, in current in different loop, current here, right? Suppose this is I1, this is I2, and this is I3. Okay, or we can say this is I2, I3, and this is I2. This is I2. Okay, so we have to find current in the loop. Okay, we have to, or we can say we have to find I1, I2, I3. Okay, so we can solve it by nodal analysis using KCL, and that is going to make our calculation easy, and we can easily solve many complicated circuits, right? Easily solve those circuits, and then solve that question. Okay, so here it is E, guys. It is R1, this is R2, and this is R2, this is R4. Okay, so how we are going to find the nodal analysis, how we are going to use that, I'm going to tell you guys. Understand. Okay, what we will do is we'll choose any one point. Okay, uh, and we'll suppose the voltage at that point is X. Okay, so we can choose any point, but we'll choose that point which will make our calculation easy. Okay, so here we have chosen this point, and the voltage at this point is X. Okay, and this is E, so it means the voltage at here is 0, and this is E. Okay, similarly the voltage is 0 here, voltage is 0 here. Okay, now we are going to use nodal analysis, right? So here okay, so now we'll use it. So guys, very simple how to use this nodal analysis. We'll use KCL. Okay, okay, so so what we are going to do is, this is X. Okay, we'll do X minus E. This is the voltage. X minus in between there should be resistance, right? X minus E upon R1. Again for this side, X minus 0, because here voltage is X and here voltage is 0, right? X minus 0 upon these two resistances are in series, right? So R1 plus R2, and for this is going to be X minus 0 upon R2 equal to 0. Okay, that's what we are going to do. We are using KCL. So for the equation, for this equation is going to be, for this circuit is going to be X minus E upon R1 equal to X minus 0 upon R2, R3 plus R4, R3 plus R4, my apologies, it's plus. Okay, this is plus, and then plus for this X minus 0 upon R2 equal to 0. Okay, so we have used KCL. Current at junction is 0, right? So X minus E, this is the word X minus E, this one X minus E upon R1 plus X minus 0 upon, these are in series, that's why R3 plus R4 plus X minus 0 upon R2. Right now, what we need to do is we need to just solve it. So here at this point we'll get the value of X, that is the voltage we'll get here, right? So now we can easily find out the current I1, right? This is E, there is a voltage draws, right? I equal to that V upon, because by this formula, Ohm's law, right? V equal to IR, right? So from here I equal to V upon R, we will find the equation, right? So now we are going to solve it. Very simple. Now let's say R1 equal to R2 equal to, for solving it, okay, R3 equal to R4 equal to R. Okay, these values are at there, R. Okay, then equation is going to be, X minus this one, X minus E upon, this is R. Okay, R1 equal to R plus X minus 0 means X, x upon r3 plus r4 means r plus r 2r, right? This is going to be 2r equal to this one. X minus 0 means x upon r2 means r, x upon r equal to 0. R will get cancelled, so this is going to be x minus e. These are plus, guys, sign, my apology, plus sign. Okay, so this is plus. Very simple, guys. Just what we need to do is we just need to select one point, and there will suppose the voltage is x, and then from this x minus this, x minus this, x minus this upon r. Okay, like that. So this is 1 by 2. It's my apology, x by 2, x by 2 plus x equal to 0, right? So this is going to be that if we solve it, this is going to 5x by 2 minus e equal to 0, and from here value of x is going to be 2e upon 5. Okay, so now we have got the value of x, and now very simple, we can find total current or current in this loop, current in this loop, current here, right? So very simple. So now that implies I1 we can find out. Okay, I1 is going to be this current, I1 is going to be voltage drop, that is x minus e upon r1, right? X is this one, 5e upon this, right? X minus e upon r1, right? So this is going to be x is 2e minus 5 minus e upon r. R1 is r, right? R. So this value is going to be that I1 is going to be equal to this. We solve it, right? So minus 3r, minus 3 upon r, right? Minus 3e upon r, minus 3 upon r. Okay, so you can see we are getting negative sign, right? So here we have, suppose the direction is like this. Okay, so it means the actual direction is, because minus, so direction of I1 is this. Okay, similarly we will find I2. I2 is this one, x minus 0 upon r2, right? So this is going to be uh, x minus 0 upon r2, that is x is, value of x is this one, 2e upon 5, 2e upon 5 minus 0 upon r, right? So this is going to be 2e upon 5r. Okay, the current direction is the correct which we have taken. Okay, this one. Now similarly you can find I3. I3 is going to be this one, I3. This is x minus 0 upon r1, r3 plus r4, x minus 0 upon r3 plus r4, right? So x is 2e upon 5 upon 2r, right? So 2 will get cancelled, so this is going to be 2, e upon 5, e upon 5r. Okay, this is the answer. This is I3. So we can easily find out this. Now you can see how quickly we have solved this question, right? And it's very simple now. So by that we have easily found R1, R2, I1, I2, I3, right, and X, right? We can use loop analysis as well, that is KVL, that I will explain later. At the moment we are using nodal analysis. Okay, so I hope guys you have understood it. Next question we are going to do, and also guys, this is very important point, you know it, I'm going to write it for you. That is, current always flows, current always flows in the direction, in the direction, in the direction of higher potential to lower potential, higher potential to lower potential. Okay, very important point. current always flows in the direction of higher potential to lower potential. So the current will flow from higher potential to lower potential, like right, like in temperature in that energy flows in energy flows from high temperature to lower temperature, right? Similarly, the current in thermodynamics, so similarly, current flows in the direction of higher potential to lower potential. Okay. Well, now next question we are going to solve by nodal analysis. Next question is question number 2. This is given, guys, this one. This one, okay. This is 0, this is 0, this is 0, and this is E, and this is 2E, guys, okay. So we have to solve it by using nodal analysis, okay. And these values are R, and R, okay. This is 2E, 2E, this is E. Okay, so how we are going to solve it, guys? So again, we'll choose a point, and there will say the voltage is X. Okay, so we can choose any point. So I'm choosing this, and it is better to choose that point from where calculation are easy. Okay, from where our calculation will be easy. Okay, so this is X. This is, we have taken this point as a X. Okay, so here you need to understand, guys. These are 0 voltage, right? So the voltage at this point is E, and the voltage at this point is 2E. Okay, this is 2E, this is E, and this is E, this is 2E, this is E, this is X. Okay, now we can use the analysis, nodal analysis. By nodal analysis, what? X minus E upon R, X minus 2E upon R, X minus 0 upon R, right? So this is going to be X minus E upon R plus X minus 0, this is also R, okay. X minus 0 upon R plus X minus 2E, this one, X minus 2E upon R, X minus 2E upon R equal to 0, right? Very simple. Now we'll solve it. So RR will go, because R is here, so this will go in right hand side. So this is going to X minus E plus X minus 0 plus X minus 2E equal to 0, right? So from here, the value is going to be value of this is going to be 3x minus 3e is going to be 0. So implies value of x is going to be, value of x is e, right? Now we can easily find out I1 and I2, right? Next page. So I1 is going to be, so we can say this current is I1, this is I2, and this is I3, and this is I2. Okay. So from here I1 is going to be simple. I1 is x minus e upon r, right? I1 is I1 is x minus e upon r, right? Value of x we have got, right? So e minus e upon r. So value of I1 equal to 0 means current here is 0. Okay, now I2, it is going to be x minus this one. This is I2 and this is I3. Okay, I2 is going to be this one, x minus 2e upon r, right? X minus 2e upon r. So this is going to be x value is e, right? So this is going to be E minus 2E upon R. So this means minus E upon R. Minus E upon R means I2 direction is, direction of I2 is, this is not the direction of I1, right? So direction of this we have chosen. Now direction is this. Okay, minus. Similarly, I3 we can find I3 is going to be this one, x minus 0 upon R, this one, x minus 0 upon R, right? So x is this E upon R, right? So this is the direction is correct. Okay, so this is how we find the value of current in this circuit. Okay, without using KVL. So we are using KCL, that is nodal, by nodal analysis. Okay, very important method, guys. Okay, so now next question, question number 3 we are going to do. Okay, question number 3. Question number 3. Question number 3 is, question number 3 is, it's also a good question, guys. Question number 3 is this one. We have circuit like this. Okay, so we can get different type of circuit. Very complicated circuit can be easily solved by using nodal analysis, guys. Okay, so very important method. And this is like this. Okay, this one. So here we have been given, this is E, this is 2E. Okay, now here you can see the direction of this is different, right? It is E and this is 2E. Okay, so how we are going to solve it? This is important. This is R, this is R, and this is R. Okay, so we have to solve it, guys. Again, we'll choose one point. We are choosing this point. Okay, X. Okay, so now we have to be very careful of choosing these values, guys. These values should be same. So how we are going to get this value same, right? So for getting this value same, we can do is like this. We can do this value is minus E and this value is 0, because if we subtract 0 minus minus E, this is going to be, right? Why? And because we need minus E in this side, right? E. This is also minus. Okay. Minus, and here we have to say minus E means this is going to be minus E and this is going to be that is minus 3, minus 3. Okay, minus E and minus 3, because if you subtract from minus E minus 3E, right, this is going to be plus 2E, right? This we need to, so here you have to be very careful. So what is the difference between this question and previous question, right? The sign of voltage is different, right? So for that, right, we have to, what we are going to do, because we need minus here, right? Same voltage, so we can take it, we can take it at minus E and 0, because if we get the difference of it, we are going to get E. Similarly here, if you get if you will get the difference of minus 3 minus E minus 3A, right? So this is going to give 2E, right? So this is how we have got these values, right? The values of voltage. Now we can easily use nodal analysis, KCL, right? So this is going to be simple. X minus 0 upon R, x minus plus x minus minus E upon R plus x minus minus 3E upon R, right? Simple. So by nodal analysis, it is going to be x minus 0 upon R plus x minus minus E upon R plus, will jump from here, and from here, right? These are the jumps we are going to do, right, for using this. And this is going to be x minus minus 3E upon R equal to 0. Now we'll solve it very simple. So this is going to be x plus e plus x, right, plus x plus 3 is going to be 0, right? So from here value is going to be this is going to be 3x plus 4e is going to be equal to 0. So from your value of x equal to 4e upon 3, right? So now we can easily find out the value of I1, I2, I3 if you wanted to find. Okay, simple. It's just if we have to find I1, so we can say x minus 0 upon r, and x value we have already 40 upon 3, right? This is the nodal analysis, guys. Now next question we are going to do. So there are different types of questions, guys, so you have to be careful how to choose voltage, okay, and how to use this analysis. Okay, this is important. Next question, guys. This I'll make a circuit. This is the one, and then this. Okay, so this is 20 ohm and this is 10 volt. Okay, and this is 40 ohm, this is 10 ohm, and there is one more. This is 20 volt. Okay, this is the one, guys, and we need to find out the voltage and then I1, I2, right? So we can easily use how we are going to use nodal analysis here. Again, we'll take any point that is x we have taken here. Okay, we have taken this point, this is voltage at this point x. Okay, now we need to understand, guys, this is 20 volt, means this is 20 volt, this is also 20 volt, right? And this is 0 volt. Okay, this is 0 volt. Now how we are going to take a voltage here, right? So this is x volt, right? So this is going to be x plus 10 volt. If we get the difference of this is given to x plus 10 minus x, it is 10, right? So here it is voltage is going to be x plus 10. Okay, and similarly this is 0, this is also 0, right, guys? So now we can easily use the that nodal analysis, that KCL, right? Simple. We'll jump from here, here, and here, right? So this is going to be x minus. So now we'll be very careful. Okay, so we'll use this formula where from two voltage there must be resistance between two voltage, right? Then we can use this formula. So this is going to be x minus 0 upon 10, this one, x minus 0 upon 10, plus this one, x minus 20 upon 40 volt, right? Plus this is here we cannot use because between here there is no resistance, right? So there is voltage. So we'll use this nodal analysis here. X plus 10 minus 0 upon 20 equal to 0. This is very important point, guys. Okay, simple. This is very simple. X minus 20 upon 40 and x minus 0 upon 10, right? Here there is no resistance between this voltage and this voltage, so we are not going to use KCL here, right? We'll use nodal analysis between here because between these two voltage there is a resistance, right? So then x plus 10 minus 0 upon 20, right? So from there we can easily find the value of, so this is going to be x by 10 plus this is going to be x by 40 plus this is x by 20 minus 1 by 2, 20 upon 40, right? And then this is going to be minus 1 by plus 1 by 2, right? This is plus 1 by 2. This is going to be equal to 0. So from here we can easily get the value. So value of x is going to be, so from here value of x is going to be 0, guys. Okay, if you solve it, very simple. If you solve this, this will get cancelled. Okay, so if you solve it, so this is going to give this one. 40 will be LCM. Okay, 40 is going to be LCM. 40 is going to be LCM. Okay, so 40 is LCM, and this is going to be x plus 10, sorry, going to be 4x plus x plus 2x equal to 0. So 7x equal to 0 implies x equal to 0, right? And we've got the value of x here, right? We can easily find out value of I1. I1 means x minus 0 upon r. Similarly this, okay, simple thing. We can easily find out the resistance. See, this resistance is r, right? This is the r. Okay, no, this is have you made any mistake? This is 20, guys. Okay, so 20 yes. So we can easily find out this one, x plus the, for this current, the here it will be the current, right? X plus 10 minus 0. For this current, x minus 20 upon 0. Simple thing, guys. Okay, this is the nodal analysis, guys. There is one more question that I'm going to solve, and then we'll end the class. Okay. Okay. So question is simple. I'll make a diagram first. This one. Okay, so this is the question, guys. This is a very good question. Okay, and this is 4 ohm. This is 20 ohm. Okay, this is 4 ohm. This is 2 ohm, and this is 2 volt, and this is 6 volt. Okay, this is the question, guys. Okay, so now these are the, and this is also, this is 4 volt, right? Okay, so now we have to use nodal analysis and find out the current. Okay, so how we are going to solve? First we'll find the voltage. Okay, so so here we have to take two different voltages at different points, guys, because so here we are going to take one point, that is x. This point we have taken x, and this we have taken y, guys. Okay, I'll show you how. Okay, so this is the x, means this is 6 volt, right? And this is, we have found y means we need 6, so this is going to be y plus 6, because if you subtract y plus 6 minus y, this is going to be 6 volt, right? This is going to be y plus 6. So here this is 2, right? This is 2 voltage. Okay, 2, and this is going to be 0. Here this is y, and this voltage, this voltage is going to be 4, not 4, guys. Okay, because this is x. Okay, we need 4, so this is going to be x plus 4, because if we subtract x plus 4 minus x, then this is going to give 4. Okay, so this is x plus 4, and this is x. Okay, then their difference is going to be. Now these are 2 points, very easy, right? Now you can easily solve it. The main thing in nodal analysis is to choose the point, and here you cannot, so if you choose only one x, the voltage x, right, at any point, then you are not going to solve, you will not be able to solve it, right? So we have to choose two two voltages at different point. Okay, so here we have chosen X and Y. Now we can use nodal analysis. Okay, for X we'll use first. For X, this is going to be X minus 2 upon 4, right? This one I've told you how to do it. For X, this is going to be X minus 2 upon 4 plus this one X minus 4, sorry, X plus 4 upon 4, right? Plus here X minus Y plus 6 upon 20, right? This is 4, this is 20. This is 2, guys. My apologies. 2 ohm, not 20. 2 ohm, okay? And this is going to be equal to 0. This is for X, okay? So there are no other point, right? So for this, and for this. Now for Y. So for Y, this is equation number 1, okay? For Y, simple, this one. This is Y, right? For this. So this is going to be for Y minus X minus 4 upon 4. Y minus X this is X plus 4. Okay, yeah, X plus 4. X plus 4 upon 4 plus this one Y minus Y plus 6 upon 6, right? This is 6. This is 6 volt, right? So this is Y minus X plus 4 and then Y plus this one, right? Y minus X plus 4 by 4 plus Y minus Y plus 6 by 6, right? This one. So this is the one, guys, okay? So now these are equation 2, or now what you need to do is you will get one equation. If you solve it, you will get one equation in XY. Again, if you will simplify it, you will get one equation in XY, right? We'll solve that equation and we'll find the value of X and Y. Here we have got the value. I'm directly writing the value of X, Y are X value is 6 and Y value is minus 6. You can calculate it, guys, okay? Well, and then you can find out easily the current in the loop, okay? Well, guys, I'm going to stop here because I have one more class which I'm going to take, that is for thermodynamics and statistical mechanics class, okay? Just after this class I'm going to take. And also, guys, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science, guys, okay? So in next class we'll do some more questions of nodal analysis and then KVL rule will do, okay? Okay, guys, thank you so much. Bye now.